Hi, everyone. I'm Lindsay Lewis, editor of Building Enclosure. Thanks for listening along with us today. Joanna Giovanoli joins us today. Joanna is a senior marketing manager for the infrastructure and wire and cable markets at Dow, leading the development and execution of marketing strategies. She's here today to chat with us about the strategy behind high-performance building enclosures and the advanced materials hidden within our walls, floors, and foundations. Joanna, thanks for sitting with me.
Yeah, thank you so much for the introduction. Pleasure to be here.
So to kick off, let's talk a little bit about structural failures. So how can advances in material science strengthen buildings to prevent structural failures?
Yeah, absolutely. So that's actually a really good initial questions because we believe that material science is very critical to the overall products that we have in our buildings and construction. So whether it's commercial building, residential building, it is very critical to choose the right materials. And here at Dow, we have over 125 years of experience. We employ a lot of very smart people, a lot of PhDers that bend those molecules to meet the performance and requirements of the application. So we provide the polymers and the resins and copolymers to our customers who then make the final products, right? So by selecting those high quality materials, you help the infrastructure with longevity, with durability. And we like to cooperate with the value chain partners to design those products. So it is very important to have the latest and the greatest, the materials that will provide you with the performance that will meet or exceed those building codes. So here at Dow, that's what we like to do. We innovate for performance and we innovate for sustainability.
Now, at Building Enclosure, we discussed a lot about overall a building's footprint. So my question is, what role do modern materials play in extending the lifespan of critical infrastructure inside a building's footprint?
Yeah. So, for example, building on that first question, actually, with how critical materials actually are, if we take pipe, for example, and maybe it's not right in the middle enclosure, but it's right next to it, right? Pipe for gas or water, and it is again for everywhere in your city. We have aging infrastructure in North America. This is a problem, right? A lot of our pipes, for example, are lead pipes that have a lot of buildup inside of them. That's the water that we're drinking. But just beyond that, if you have cracks in those pipes, and those pipes now that are older, they're prone to cracking. And having that resistance, high density polyethylene products that are resistant to cracking, they have rapid crack propagation resistance, and that is the continuum technology from Dow that we offer. Helps with longevity and durability. So that small leak that you might have somewhere out there in the road, it will get to your house. It will get to the structures, right? And it will cause a lot of problems. So the total cost of ownership actually is very important, and there's a lot of labor shortages in the industry right now as well. So if you don't have the maintenance cost, if you don't have the repair cost, that is allowing that labor, that person to go work somewhere else and build something else. So again, going back to that material science and being strong and being designed for the structure is very important.
Yeah, going back to that material science, in what ways can material science improve the performance of building enclosures to reduce things like leaks and protect the overall foundation?
Right. So going beyond pipe now. So we talked about that. So actually that pipe will affect your foundation, right? So the crack in the pipe. Roofing is your first line of defense against weather. So whether it's going to be rain, hail, snow, ice, right? Depending on the region that you live in. We have alveoli key for PVC roofing membranes. Those membranes are actually very critical to infrastructure, to buildings such as data centers. Data centers are big right now. Manufacturing, factory buildings that house a lot of equipment, millions and millions of dollars of equipment inside. If you have a leak in the roof, that's a bad day in a data center. There's a lot of stuff inside that we have to protect. protect. So our materials are designed to work as a system they were designed with our customers to protect against those. So we have, that's just for PVC roofing membranes. PVC roofing membranes are actually very important because they also are self-extinguishing in case of fire. So that is very important, for example, for a data center that houses what billions of dollars of equipment. Nordell EPDM for EPDM roofing membranes offers durability, resilience, flexibility. It's very important to have those tough materials protecting overall buildings.
Now, shifting a little bit to sustainability, what are some emerging sustainable materials that balance environmental responsibility with durability and safety?
Yeah, so when we started this conversation, Dow, I was mentioning that Dow likes to design and innovate for sustainability and also for performance, right? So we don't forget about sustainability, and it goes beyond our walls of our factories, where we reduce waste, right? We look at what we can do inside, but we design products such as Revolut product that will contain 10, 20, 50, even you can get 100% PCR, so post-consumer recycled product. And you take that product and you put it into, and you formulate with it, you put compounds into products that were made with the virgin materials. So for example, inside the walls of your building, you have wire and cable. Such product actually with Revolut is we have designed one product for cable jacketing. So you're diverting waste from the landfill. The one thing, there's a lot of science in processing these materials because you're basically taking your my trash from the curbside or your grocery bags from your local grocer, and you need to now process it into a product that you can use into polymer resin pellets. There's a lot of science that goes into it, and it's very challenging. Another product that we developed is Engage REN, which is polyolefin elastomers, and those are biocircular attributed raw materials. It's a lot of words in there, but that's a biocircular materials that go into that product that actually offer carbon negative offering to our customers that want to meet their sustainability goals. And it is pretty difficult. They have very lofty goals. And how do we meet them? And it's by going back to the basics, to the chemistry of these things. So Engage REN, we are designing a non-PVC luxury polyolefin tile so that it goes inside the building. And it's also for carpet backing for commercial tiles. Very tough endeavor actually, because PVC is a good material as far as toughness, as far as durability, how hard it is, right? So there's a lot of science and challenges that goes into designing that and taking the PVC out. And if I can add one more thing in this very important part, so if we're looking at roofing again, our alveoli key material that goes into PVC roofing, it's actually non-migratory. So a lot of liquid plasticizers out there, they leach out to the environment, and over the years, they leave the roofing membrane non-pliable. So it'll be not flexible, and then it's prone to cracks. Ours stays right into in the formulation, right in the structure of the polymer.
Now, going back to the topic of carbon, how does the choice of enclosure materials impact the overall energy efficiency and carbon footprint of the building?
Yeah, so we talked about sustainability, quite a bit already. One of the things that I can talk about is there are climate zones in the United States, for example, where they include roof reflectance requirements, and those roof reflectance requirements are to protect the building from heat, right, from heating up. So it depends on the region and the zone, climate zone in the United States. So we work with our customers to help them design the right products. So it's overall roof system, actually. It's not just the membrane, but depending, like if you can make the membrane a little bit thinner or a little bit, if you need it a little bit thicker, that can help with those kind of things. And our customers then can design their system accordingly. So I mean, roof is a really good example for this particular question because it protects you from heat, from everything else, right? Water, everything else that we've been talking about.
Well, another topic that gets talked about a lot in our industry, especially as of late, is extreme weather. So my
Yes.
question is, how can material science innovations help architects design for resilience against climate-related stresses like we've been seeing, like hail and flooding and everything else?
Yeah, so we can't us can't, us here can't prevent weather events, right? So how
Mhm.
do we try to protect ourselves and our buildings from that? It really, again, goes back to the choice of the materials that you have and the overall system. We have a problem that cannot be solved by one person, by one company, by one organization, by one industry organization. We have to all collaborate and work together to resolve those problems. But beyond that, even like from designing what you can do for resiliency, so you go, tough materials, tough products. But even beyond that, after the weather event, what do you do and how fast can you get up to running again, right? Up to your daily life again. And so ease of installation is very important in this industry with the shortages of labor. You need pliable, flexible, lighter materials. Then you can throw that roof on and move on to your next building. So that's very important. So how do we all work together to design those systems to be able to do that and let us, right, all of us to get back to our daily living. So speed of installation, ease of installation after the weather event is very important as well.
Now, lastly, I do want to ask, what lessons can be learned from past building failures that material science can help us prevent in the future?
So that is an excellent question. And we like to work together with our customers, and that is key. Like I said, there's not one organization that can solve these issues anymore. We have to work together. So I don't know that there's a really good answer. Hey, I have this polymer that will solve all the problems. There is no silver bullet anymore. We have to all have the collaboration, and we're seeking those opportunities with our customers of how do we get involved with the broader industry? How do we work together to have that polymer scientist, to have the application expert, to have everybody working together on designing that system that will help us protect ourselves from that building, from the weather, and then come up to speed as fast as we can after.
Well, thank you again, Joanna, for your time today.
Thank you so much. It's a pleasure to be here.
If anyone listening has any questions, please feel free to reach out to myself or Joanna, and we'd love to continue the conversation. Until next time, visit us on buildingenclosureonline.com for your technical and educational resources.